Enzymes are proteins that allow biological reactions to occur quicker than the reactions would occur on their own. Enzymes function as catalysts, which means that they speed up the rate at which reactions occur in living organisms. Enzymes are usually part of a larger enzyme pathway. An enzyme pathway is kind of like dominoes. The products of one enzyme reaction become the reactants of another enzyme reaction. So if one enzyme does not function correctly, the pathways will be incomplete, causing issues for the organism. A common example of the result of an incomplete enzyme pathway is lactose intolerance. Enzymes work by binding to reactant molecules and holding them in such a way that the reactions take place more easily. Molecules called substrates bind to the enzyme at the active site. The active site is where the catalytic activity occurs. The performance of an enzyme is similar to the performance of a car. Car buyers look for factors such as how many people the car can hold at full capacity and how fast the car can go from 0 to 80 miles per hour. In a similar way, scientists evaluate the performance of an enzyme by analyzing the concentration of substrate at which an enzyme is saturated and how fast it can convert the substrate to product under various conditions. Efficient enzymes can become saturated and catalyze substrates quickly. An enzyme becomes saturated when all of its active sites are occupied with catalytic activity. The efficiency with which an enzyme interacts with a given substrate can be determined by two values, Vmax and Km. The relationship between Vmax and Km can be visualized in the Michaelis-Menten Enzyme Kinetics model. Vmax is the maximum rate of reaction that a particular enzyme can achieve. In the car example, this would be like how fast a car can go from 0 to 80 miles per hour. Km is the substrate concentration that is halfway to Vmax. While the Vmax value changes when the substrate concentration changes, the Km value remains constant for a particular enzyme and is a measure of an enzyme's tendency to bind to its substrate. As the Km increases, the affinity that the enzyme has for the substrate decreases, and as the Km decreases, the affinity that the enzyme has for the substrate increases. The Vmax and Km values that provide insight into the kinetics of an enzyme aid in the design of drugs. Most drugs serve to inhibit enzymes. The design of potent inhibitors is crucial for drug design, so enzyme kinetics plays a large role in this process. Computational modeling and simulations are amazing tools for designing and screening inhibitive drugs. With advancements in technology and the increase in availability of such tools, drugs for diseases can be designed by anyone. Maybe you could be the one to create the next breakthrough drug.